Let's look at this example. The tendency of urethral stents to fracture in vivo is reported 0.5%. Calculate the probability that the two urethral stents will fracture in vivo in a clinical trial of 200 patients. Now first we have to identify what sort of equation should we use. Should we use a binomial or Poisson equation? In this case, since it's a rare event that occurred over some interval, in this case the urethral stents to fracture. Alright, so this is a type of a Poisson distribution. Now just like the binomial distribution, the Poisson distribution also has its requirements. The first requirement is the random variable x is the number of occurrences of an event over some interval. In this case, x is the urethral stents that tend to fracture in vivo. Okay, so this is a rare event. Second, the occurrences must be random. Third, the occurrences must be independent of each other. So whether it's fracture or it does not fracture is independent to each other. Now the occurrences must be uniformly distributed over the interval being used. So here I've listed down what are the requirements. In this case, all these requirements has been fulfilled. So we use a Poisson distribution formula to calculate what is the probability that two urethral stents will fracture in vivo in a clinical trial of 200 patients. Now this here is the Poisson distribution formula. The mu is the mean. X is what we're looking for. In this case would be the two urethral stents. Alright. E is a constant value of 2.71828. Alright. So now what we're looking for, X is 2. Okay. X is 2, N is 200, and the P value here is 0.005. Where did I get the value? Okay, it's here. The tendency of urethral stent to fracture in vivo was reported to be 0.5%. Okay, so the 0.5% is the P value. So to get the min, you have to multiply N against P. So N in this case is 200 multiplied by the P, probability of getting a fracture is 0.005. So the mean value is equals to 1. Now once you've identified all the values, now put them into the formula. You can use your calculator and calculate, and this is what you get. Okay, the probability that two urethral stents will fracture in a clinical trial of 200 patients is 18.4%. Now interestingly, we can also use binomial distribution to estimate the probability of this Poisson distribution, but it has got a few rules that you have to fulfill. One is N must be a large number. Okay, it should be more or equal to 100. In this case, we have N of 200, so it fulfills that first requirement. Okay, and the second requirement is N multiplied by P should give you a value less or equals to 10. Okay, so N multiplied by P, which is the mean value, in this case is 1. Right, so it is definitely less than 10. Okay, it's definitely less than 10. So we can use the binomial distribution formula to calculate what is the probability of two urethral stents to fracture in this case. Okay, so this is the binomial distribution formula. Okay, now put in those values. N, which is 200, X is 2, P value is 0.005, the Q value is 0.995. How did I get this? it's 1 minus p. Okay, 1 minus 0.005. Okay, so we've got the same answer here. So the probability that two urethral stents will fracture in a clinical trial of 200 patients is 18.4%. So the answer is the same as when you use the Poisson distribution. Now you have to remember, you can use the binomial distribution formula, but it should fulfill these requirements before you're able to use it. Okay?